So you're going to have the formula, you're going to have the charge, but you actually know what to do with them. So let's take up a problem, shall we? Shall we try to do magnesium and shall we try to do magnesium and compare the force of magnesium to the force in sodium? Want to try it? Okay. So get your calculators out. We have to write out our formula. Our formula is this. If you look at magnesium, I wrote down specifically, if you go back and look in your notes, exactly how many protons I have and exactly how many electrons I have. I'm going to use those numbers in this problem. That's one of the reasons why I chose to write them down. So, protons, I have 12 protons and I have 10 electrons. I'm going to have to multiply that by the charge of an electron and the charge of a proton. So it's going to look like this. Does that make sense to you? So each proton has this charge. Each electron has this charge. I don't have 1. I have 12. So do you understand why you're multiplying? Yes or no? Do you understand why you're multiplying? Well, you have to talk to me. Do you understand why you're multiplying? So what we're going to do is we're going to get these numbers, and then what we're going to do with these numbers right here? We're going to end up putting them down. We're going to end up multiplying them. So let's put them into our calculator, which is what we were learning yesterday. We have 12. So you want to see my screen, or you want to see me push the keys? Push the keys. Okay. So like every time I push a key, you want me to show you the screen? Oh, when it's done. Okay. So I'm going to put in 12 times this number here. So I have the 12 in. I'm going to put times. And I'm going to put this number in, which is a new part for us. So I'm going to put in 1.6. And then I believe your key is blue. Mine is yellow. And you want this E here. You want this E to be there. Because this E is this right there. So you don't have to do any fancy exponent stuff. You don't have to do any of that. Then you're going to put in the negative 19. So this number right here and that number right there, that's what this number looks like in your calculator. Does that make sense to you? So E means times 10 too. I don't have to. If you wanted to do it in one big shot, you could. If you want to do it all in one big hit, like if you wanted to do this times that, then you have to put parentheses. No, you don't have to put parentheses in because you're using that EE key. Okay? Alright. Now, we're going to do the next one. And remember, it's a negative number. And I put 1.6 second EE on negative 19. Now, what am I going to do with these numbers based on our equation? That's Q1, this is Q2. I'm going to multiply them together. What I got to make sure I do? I have to make sure I use that negative sign out there. So I'm going to multiply these together. But I have to make sure I multiply that by a negative 1 at the end. So now I have to put these little numbers in. 1.92 second EE, negative 18, times a negative 1.6, second E, negative 18, and I get negative 3.072 times 10 to the negative 36. What do you get? Do you get the same thing? Okay. Now this negative and that negative make what? Positive. And the label for force is an uppercase N if you're wondering it's in Newton. Do you want to feel how heavy 1 Newton is? Okay. This is how heavy a Newton is. Like, that's 1 Newton, exactly. It's named after he treated the servants fairly. He threw things at them all the time. Not a nice guy. But he was knighted by the Queen of England because he was pretty smart. He invented calculus. And he also invented the Newton, which is a measurement of force. And he's the guy that's having the apple fall on the head. That's fine. Do you get the joke? Okay. All right. Okay. So that's the answer for what? Which this is magnesium. Now I want you and your partner, if you have one, to get your paper out and do sodium ion. I want you to figure out the force for the sodium ion. So your sodium ion is 11, and your proton number is, your proton is 11. What did you get? Good job. So you should have 11 times 1.6 times 10 to the 19. Right? And then you should have that times 10. All of that with the negative. And you should get 2.816 times 10 to the negative 36. Do you agree with that? So if you're going to put it into your calculator in one shot, that's what you would do right there. You can do it all together at once, or you can do it together in pieces like I did up here. You have options. Which one you enjoy is the one you get to pick. So this is sodium. Can anybody not get that number? Does anybody need to put it into their calculator? Because you have to know how to do this. Because we're going to continue to use these numbers for the rest of the year. We're not just going to forget about it and leave it behind. Okay? Now, I have a question. Which number is higher? Which number is higher? Which one's greater? Magnesiums or sodiums? Magnesium So that means that the force between the electrons here and the nucleus is greater than the force between the electrons and the nucleus here. So because of that, which one do you expect to be bigger or smaller? And that is correct. It is indeed smaller. You see how I did this? Okay. Does that make sense? It's not rocket science. Okay. So, can you do that? Can you do that now? Okay. Can you do this? Just so you know the picture right here. You can really describe that using numbers. Yeah. Okay. Can you argue the difference between inner and outer electrons? Okay, now there's something we haven't talked about yet, and that is another part of this equation. And that was on page 6. It was the radius. So we just explored this part. Now we're going to explore the radius. What does the radius mean? So now let's add that to our equation. R is the radius. And it needs to be in meters. And it is the distance between Q1 and Q2. So it's how far apart is Q1 from Q2. So this is not a factor that comes into play. So when you were adding and you had to do some adding of electrons and remove electrons. What happened to the size of when you were doing this right here? What happened to the size of your lithium atom when you took an electron away? Do you remember? It got smaller. And we need to talk about why it got smaller. So to answer this right here, the force between a single electron in the nucleus is attractive. And as you add electrons to an atom, it makes it more negative. What happens to the force? The force between a single electron and the nucleus is attractive, and it stays the same. The force between a single electron and all the electrons is repulsive, and that changes. So if you add an electron, that's going to increase, right? The net force the electron feels becomes what? More repulsive, right? Because there's more negativity around them, right? Okay, so now let's could you use this equation to use numbers with this? So like, let's say the distance is increased by 2. So let's increase the R by 2. So whatever R is, you're going to give R a number. Let's say R is equal to 5. If I increase by 2, what would R become? So I would take 5 times 2. That would be 10, right? So what would happen to the force? So let's give this number right here a number. Let's say that's 100. What's 5 divided by 100? What? What's 5 divided by 100? Anybody? Yeah, I'm sorry. I said 20. What is 100 divided by 10? So what happened to the force when I doubled the distance? What happened to the force? It decreased what? By, yeah. Want to try a different number? Let's try a bigger one. How about let's make a radius 100 and let's double it and that's 200. So let's put the numbers in. We're going to keep our chart up top 100. So 100 divided by 100 is 1. 100 divided by 2 is... Oh, we're screwing up. What's wrong? Made a mistake. What mistake did I make? The radius is squared. Shame on me. I'm not following the equation. I need to square the radius. So far is 5. Let's start over again. And in the equation, I have to make sure I square it. So 5 squared divided by 100 is what? So 100 divided by 2 is what? 4. And now I need to take 100 divided by 10 squared. What's 10 squared? So 100 divided by 100 is 1. How much did the force change? When I doubled the distance, what did the force do? It decreased by what? Well, think of it as it was 3 times smaller, right? The force decreased. Let's see if that holds true. Let's do my radius on 100, and let's make this one 200. So 100 squared. Help me out with math. Math teacher calculator. What's 100 divided by 100 squared? It's going to be a small number. Need a decimal. So that's 100, like that. Do we? I'm not. I don't know. I'm trusting you. Please put it into your calculator and see. Okay, so you said this was 3 times because you have 4 minus the 1. I'm not completely sold on that. I'm looking at times, not subtraction. Okay? So how many times smaller was the force here? 4 times, right? 4 times 1 is 4. We're looking to see if that's true. Did you get here? Do you agree with that number? It's what? Okay, what did you say? 0.01. Okay. All right, thank you. What about this? What'd you get there? Say it louder. 0.0025. So how many times larger or smaller is that? How many times? If I take this times 4 like that. Try it. No. Okay. How many times smaller? It's okay. So is this one still times 4 times smaller? Yes. So what can we say? If we have a radius, what happens to the force? It's 4 times smaller, so make sure you write that down. You just proved it mathematically. I used the equation to prove that mathematically. You saw I had quantitative evidence to prove my reason. I do this, and I double it. If I double the radius, the force decreases by 4 times. So every time I double the radius, the force decreases by 4 times. Add this equation. And I use numerical evidence to prove it. Okay? All right. So I think we're good. Now, let's list what the things you need to study for our quiz tomorrow. For our quiz. Do you remember? The activity summary. Yes. So when I go there, you need to study. So we have our driving question board. What did we do in lab 1? We didn't put anything on our activity summary board. What did we do in lab 1? Do you remember what we always do in our first lab? I always show you a phenomenon, and then what do? We wonder. So maybe you should write that down. Somebody needs to put a sticky note up here and say, hey, we learned how to ask questions. Looking at phenomenon. That's what do we do in lab 2? Somebody wrote it right there. That's awesome. We studied the amount of energy to remove an electron. And what was that called? Do you remember? Not a special name. Ionization energy. So looking at all the stuff we discovered about ionization energy, we linked that to the electron configuration. Here we put 2 labs together. In those labs, we were looking at what? We discovered that some particles are charged and other particles are neutral, right? So you might want to add that here because I don't think anybody put that on a takeaway. Or maybe we should add it up here. We discovered that particles have charge. There are negative particles, there are positive particles. And then there are neutral particles, right? So you might want to add that to that right there. In lab 5, what did we discover? We discovered all about negative ions, right? We talked about anions. We talked about how big they were. We talked about how stable they were. We talked about where their electrons were. We talked about why they were negative. And then we compared them to neutral elements. In lab 6, what did we discover? Actually, I lied. In lab 4, we talked about anions. And in lab 5, we talked about cations. We talked about positive ions. Right? And what did we discover in lab 6? We just got done with it. We haven't put anything up there, so maybe you could jump on and everybody could add a sticky note. We have a lot of evidence right now. You could take pictures of what we just wrote down. What were your takeaways? Takeaways are the things that you're learning objectives. So it would be awesome if you could add that to that. Okay? So make sure you study your learning objectives for each lesson because I always gave them to you when we gave you notes. Okay? And that's what I'm going to be testing you on.